Inverses. What's an inverse? Huh? Oh, reciprocal? So if I say x,
and the opposite side. Shut up, I don't know what I'm talking about.
what's that answer then, Smarty? You're right.
Okay.
What is it? Yeah. So 1/8 and 8 are inverses of each other, right? Because it gives us the identity. So if I took 5 times 1, it equals 5, right? Yeah. This is called the identity. All good so far? Just some vocabulary, make sure we understand inverses and identity. Okay, well, we really want to talk about matrices and matrix equations. Inverses of matrices and matrix equations. So this is the same idea, but you're dealing with matrices. Now, this is the difference between people who work on a line in a factory and people who make 6 figures calculating productions and stuff. So like every line that you have of whatever it is you're producing has different variables in it. Literally x's and y's and z's. Whatever it is that each line is doing. You have multiple lines of production. So you're going to have multiple equations with multiple variables in them. If you understand matrices, you can use matrix operations to solve and understand how your business is running mathematically and use that to help reproduction. So this is the purpose, one of the many purposes of matrices, not the only purpose, but there's lots of applications in your book, many of which I think are totally useless, but they're there to help strengthen your view and understanding of how to work out matrices, okay? So let's just take this basic concept and apply it to 2x2 matrices to start with. Okay, so here is an identity matrix. And we're going to say that's I sub n for identity. And you should understand real quickly what it is that I'm writing on the board. That's a 2x2. Here's an example of a 3x3 identity. And a 4x4 identity would look like, and a 5x5 identity would look like what? You've seen this before, so what would a 4x4 look like?
4, 4, 4, 4. That's 4x4.
Yeah, it's 4x4, but what would be in it?
It'd be 0, 0, 0, 1.
Yeah, your ones would still be in the diagonal, and above and below the ones would be zeros. 5x5, 6x6. And you've been taught in pre-algebra and algebra how to solve 2 equations and 2 unknowns. That's how chapter 10 started, by doing substitution, elimination, and graphing. And then we got into x, y, and z, and we had 3 dimensions. Well, with matrices, you can solve any size. It doesn't just have to be x and y. Okay, it can be multiple variables. That's why matrices are very important, because it takes us to the next level. So this is pretty much college level stuff we're doing, but we're going to do it on a basic high school level to make sure we understand. Today we're going to do 2x2s. Tomorrow we'll do 3x3s. I split it apart so it's not so difficult. All right? So let's just talk about 2x2s. Now, the identity in a matrix looks like this. The identity in basic algebra looks like that. Plain and simple. All right, so let's just talk about something basic here. If A times B, matrix A times matrix B, equals matrix B times matrix A. Okay? Meaning 2 times 3 is the same as 3 times 2. It's the same type of thing. If those are equal, and that equals, when you multiply those out, it equals the identity matrix. Meaning, if something times its inverse equals the identity, that means they are inverses of each other. So what that is saying is then A and B are inverses of each other. That's all that says. Just making sure we have an understanding. So if you think of the algebra behind it, it's useful. Alright, so shut up and let's actually do something interesting. Alright, number 4. Here is matrix A. 2, negative 3, 4, negative 7. Matrix B is 7 halves. And yes, you're going to deal with fractions. 7 halves, negative 3 halves, and 2, negative 1. Multiply those two matrices together. You guys remember how to do that? That was section 4. Would you like me to get you started? That's right, the other classes. Half of them, remember. Alright, so I'll write out the long one. So this row times that column is going to give me row 1, column 1. So 2 times 7 halves plus negative 3 times 2. So that row times the column, you add the two entries together. Everybody see it? You gotta be good at doing this. Then the first row times the second column gives me 2 times negative 3 halves plus negative 3 times negative 1. And to get the bottom one, this row times the first column. 4 times 7 halves plus negative 7 times 2. 4 times negative 3 halves plus negative 7 times negative 1. Everybody do that calculation, please. Figure those out. You gotta understand fractions. This is why we do multiplication apps. Which one was that?
1.
Okay. Just want to make sure we're leave it. Alright, those of you still struggling, pay attention. Those of you who aren't, go ahead and finish it. You can multiply fractions together. You can divide diagonally, reduce diagonally. See, 2 over 2 is 1, so that's 7. So 7 plus, that's negative 6. That gives me 1. Again, that reduces. That's negative 3. And that's positive 3. That gives me 0. Here, that reduces to 2 over 1, or 2 times 7 is 14. Put it down here. And negative 7 times 2 is negative 14. 14 plus negative 14 is 0. Again, over here, reduce it diagonal. You don't have to reduce it. That's negative 6 plus 7. That's a positive 1. And that is the identity matrix. So, yes, these two are inverses. Or I could say B is the inverse of A. That's really what it's asking you at the beginning of your assignment. So this is the beginning part of your assignment, multiplying the two matrices together to see if you get the identity. If you get the identity, and it has to look just like that. If you get the identity, then that is that you know that B is the inverse of A. Got it? All right. Now, that's the first thing. The second thing, the last thing that we need to make sure we understand is how to find the inverse of a 2 by 2 matrix. How to find the inverse of a 2 by 2 matrix. So you want to put this in your on your reference sheet. You should have gotten this from Algebra 2. It's okay if you've forgotten. If you did it all on your calculator, which you probably did it on your calculator, you need to make sure you get this. So keep your reference sheets for when you go to college, so you can remember how to do it. It'll also be in your books, but it may not be explained like your notes. Hopefully you're taking good notes. All right, so here's the basic part of this. Given a matrix A, B, C, and D, a 2 by 2, 3 by 3 will be tomorrow, we calculate a little bit differently. A, B, C, D. How you calculate it is this. First of all, that little symbol there means you're talking about the inverse. Does that ring a bell? Alright, so this equals 1 over A times D minus B times C. Or C times B, doesn't matter. How did we get that? That's this diagonal multiplied minus that diagonal multiplied. Does that look familiar at all? We did that? Check.
Mm-hmm.
A little bit. Told you it was going to come back. In the 3 by 3s, it'll look a lot more familiar. Okay. Anyway, this is how you do the 2 by 2. This just gives you a value, a number, or a fraction, a scalar that you're going to multiply through the 2 by 2. And what is the 2 by 2? That has to be different as well. It's not this 2 by 2. You switch the first diagonal. Okay, so A and D are here. You switch those positions. The other diagonal, you change the signs. So the opposite of what they are, minus B and minus C, negatives. If they were negative, you'd make them positive. All right? That is what you should put on your reference sheet to remind you how to do it. To find the inverse of a 2 by 2. All right, now let's do a problem that has this in it, all right? So number 10. The matrix is 3, 4, 7, 9. All right, so everybody plug those values in to the formula, and I'll work it out with you. And that will tell us, what's the matter? That will tell us what the inverse is. So, the inverse is supposed to be 1 over 3 times 9 minus 7 times 4. 3 times 9? 27. 7 times 4? What's 27 minus 28?
-1.
What's 1 over negative 1?
-1.
Times the matrix, switch the diagonal, change the signs on the other diagonal. The negative 1 just changes all the signs then. Now you could do this, I erased it, but to the first example, you could actually do this formula to A, and you should get what B is if it's the inverse. You could do this instead of multiplying the two. Alright? I don't care how you do it. You should probably do it both ways to make sure you are fluent with it. Alright? Now, you found it. This is the other part of your assignment. What I'm about to do is not part of your assignment. Let's just verify that this is it. Let's take matrix A times the inverse. And that means we should get the identity when we multiply the two together. Correct? If you multiply two inverses together, that gives you the identity. So let's do that. Everybody's going to take 3, 4, 7, 9 and multiply it by -9, 4, 7, and -3. Everybody multiply those two matrices together.
Oh, okay.
No?
Is it row, column or row?
Row by column.
Okay.
we found it to be the inverse. We're just verifying that it is. Okay? Alright, so I'll write this out. You want me to just do it or do you want me to talk through it? Get it? Okay. Can't see.
I'm just a little slow in the part before that where you change it and then you change the other numbers back.
So this is what you have to memorize then. This is, you take your matrix that you have, you gotta plug in all the values and put them in this position.
Yeah.
So, and it really is just memorization. We could find out how they derived all this and got it. That doesn't matter.
Yeah.
The thing is, you just gotta remember 2 by 2. This is different than your 3 by 3. Okay, so tomorrow's gonna be totally different. Well, not totally, but this is the easy way of doing it. I'm gonna show you 3 by 3 is a little more difficult. And then we'll get into Kramer's rule. And that's just another day. So.
Is it every time you just switch them and then you just take the negatives and put them on the
Opposite side.
yeah.
Yeah. And then whatever, you gotta do this calculation here that gives you this, whatever your scalar is.
Mm-hmm.
Okay? That has to be done first, and then you have to distribute this through the matrix. This was just showing you that it worked. Not all matrices have an inverse. Okay? That's just a heads up. I don't know what your homework assignment is. All I know is not all matrices will have an inverse. If you come across one that didn't give you an inverse, then there you go. Don't knock yourself out when you're messing with it. Alright, your assignment is page 680, 3 to 15 all. That means you have evens that I expect to be done. Okay, good.